Okay, here's a graph depicting the situation. We've got the graph of y equals sine squared of x right here. And I've isolated one of the intervals where the two curves intersect, consecutive intersections. If you had to find out what those points of intersection were without a calculator, then you would be solving this system of equations right here, probably using the substitution method. And to solve this, you take the square root of both sides. So sine of x equals either 1 or minus 1. And x equals the inverse sine of 1, or x equals the inverse sine of negative 1. And where is the sine equal to 1? At pi over 2, or any multiple of 2 pi. It's like on the unit circle. Here's where the sine equals 1. And go around as many times as you want. Here's where the sine equals negative 1. And we could collapse that into these. So, and of course, this is where k is any integer. So we could let k equal negative 1, and that's where we get the negative pi over 2, pi over 2. Those are consecutive points of intersection. Now, how do we get the area between these two graphs along that interval? Well, it's the area between two curves. This is a typical rectangle right here. It's top minus bottom. So we could say the definite integral from negative pi over 2 to pi over 2 of top minus bottom dx. And I've actually evaluated that right here, 1.57. It looks like that's the same as pi over 2. And if you want to do this by hand, probably the easiest thing to do is replace 1 minus sine squared with cosine squared. And how do we get an antiderivative of cosine squared? Well, there's a couple techniques. One is to use integration by parts. So check out your textbook on integration by parts, and you can probably find something that deals with the reduction formula for cosine squared, or cosine to the nth for that matter. Or you can use a trigonometric identity. But either way, an antiderivative of squared. And so we know to evaluate this integral, we're going to evaluate the antiderivative, f of x, from negative pi over 2 to pi over 2. Or that's one possibility. So if I put pi over 2 into the f function, I get pi over 4 for this term. Half of pi over 2 is pi over 4. But if I put pi over 2 into this term, 2 times pi over 2 is pi. The sine of pi is 0. So that just becomes plus 0. And if I do the same thing for f of negative pi over 2, I'm going to get subtract negative pi over 4. Pi over 4 minus a negative pi over 4 is pi over 2. So there's your answer right there. And without a decimal, you can just say your answer is pi over 2. So check out integration by parts, or you can also use the double angle identity for cosine of 2x to rewrite this thing and take an antiderivative. Okay, there you go.